We've seen one looping statement in Python so far, the for loop. Let's review its syntax and semantics. The for loop syntax is for some variable in some sequence followed by a colon, and the statements we want to do repeatedly are indented below it. For and in are keywords in the Python language. The semantics are the variables assigned the first item from the sequence, the body is executed, and then the variables assigned the next item from the sequence and the body is executed again. These steps repeat until we've used all the items in the sequence. The sequence might be empty, in which case the loop body never executes. We've seen that lists, strings, and file variables are all sequences we can iterate over using this form, and we've learned you can create a sequence using the range function. We'll review this code that demonstrates the for loop using the accumulator pattern to add up the numbers the user enters and output the average. The first step asks the user to enter the number of values they want to add up. Next, we initialize the accumulator pattern to 0, since when we add the first number to 0, we will get the first number. The loop executes once for each number, and we ask the user to input a number and then build up the total by adding that number. When we're done, we can compute the average by dividing the total by the number of values the user entered. The downside to this program is the user first must input how many values they will be entering. This means they first need to count the number of values unless they already know how many numbers they have. One way around this is entering the numbers as one string separated by spaces or commas, and then using the string split method to create a list of each value. Once we have a list, we can determine the length of it. In these next few videos, we'll learn how to use Python's other looping statement, the while loop. The while loop is more general than the for loop, and will allow us to solve this problem in a different way without first inputting the number of values we will be entering. The syntax for the while loop is while condition colon, and then we indent the code beneath the while loop that we want to do repeatedly. This should remind you of another one of Python's statements. It looks very similar to the if statement. The syntax is identical other than one uses the keyword if and the other uses the keyword while. The semantics are different. The if statement checks the condition, and if it is true, executes the indented statements. Whether or not the condition is true, it continues after that. The while statement is a loop statement. Here's a flowchart from the book that shows the semantics of the while loop. It checks the condition, and if it's true, it executes the indented statements, and then checks the condition again. If it's still true, it does the indented statements again and checks the condition. This process repeats as long as the condition is true when it is checked at the end of the statements. When the condition is checked and it is false, Python continues at the statement indented at the same level as the W in while, just as the if statement continues at the code indented at the same level as the I in if. We'll step through a few examples to demonstrate how the while loop works. You should be able to tell this for loop example will output 0 through 4, and then after the loop completes, it prints a blank line. Note that the current value of I is 4, as that is the last value of I when the loop completes. The next fragment also outputs 0 through 4, but uses a while loop. Unlike the for loop, which automatically assigns the loop variable, we must initialize the variable used in the condition statement before the while loop. In this example, we initialize I to 0. When we check the condition, 0 is less than 5, so the loop body will execute. We output the value of I, which is 0, and increment I, so I is now 1. Note that unlike the for loop where the loop index variable is automatically assigned the next value, the loop body must change the variable used in the condition statement. We have reached the end of the code indented underneath the while statement, so we go back and check the condition again. The variable I holds 1, which is less than 5, so the loop body executes again. We output 1 and increment I to 2. The same process repeats as we output 2 and increment I to 3. 3 is less than 5, so we output 3 and increment I to 4. 4 is less than 5, so we output 4 and increment I to 5. Now when we check the condition, I is not less than 5, so Python continues at the print statement at the same level of indentation as the W in while. Also note that the value of I is 5, unlike the for loop example in which the value of I was 4 when the loop ended. We know that when the while loop ends, the condition must be false, so I must be greater than or equal to 5 when it ends. This next code fragment demonstrates that one of the loop body statements can be an if statement. This example will output 0, 2, and 4, since those are the only values between 0 and 4 that are even. We can do the same thing with a while loop. As you try to determine what the code does, execute one statement at a time without worrying about the statements that are around it. We set I to 0, and the condition is true, so we begin executing the body of the loop. The condition for the if statement is true, so we print out the value of I, which is 0, and continue with the code indented at the same level as the if statement. We now increment I so it is 1, and then we have reached the end of the code that is indented underneath the while loop, so we check the while loop condition again. 1 is less than 5, so we execute the body. The if condition is false, so we skip the print statement and continue with the code indented at the same level as the I in if. We increment I to 2, and now we've reached the end of the code indented underneath the while statement, so we check the while condition again. 2 is less than 5, so we execute the body. The remainder when we divide 2 by 2 is 0, so we execute the print statement and then increment I to 3. We check the while condition again, and it is true. We check the if condition, and it is false, so we increment I to 4. We check the while condition again, and it is true. We check the if condition, and it is true, so we execute the print statement and then increment I to 5. We check the while condition, and it is false, so we continue with the print statement indented at the same level as the W in while. This ability to use any Python statement as the statements inside if statements, for loops, and while loops allows us to write programs that can accomplish complex tasks. We can even write loops inside of loops, as we'll see in later videos. This last code fragment shows a common mistake. We forgot to change the value of I inside the loop, so it is always 0. We'll step through a few times and you can see it keep outputting 0. The loop will never end and is appropriately known as an infinite loop. We'll resume and you can see it keeps printing 0. In PyCharm we can stop this by pressing the stop button. In some console programs you press Ctrl-C to exit a program. If a program you use outside of PyCharm has an infinite loop, you might need to stop it using the Windows Task Manager or the Mac's Activity Monitor program, or worst case you can reboot your computer. The while loop can be used to do anything the for loop can. We need to assign the first value of the sequence before the while loop, and then add an extra statement at the bottom of the loop body that changes the loop index variable to hold the next item in the sequence. In general, the for loop is preferred when you can use either looping statement. The for loop is more clear, as the sequence after the keyword indicates the values of the loop variable, and you don't need to remember to update the loop index variable in a for loop. However, there are times when you cannot use a for loop. The while loop is more general and is used when you can't determine beforehand how many times a loop will execute. We'll see some examples in later videos in which the while loop is a better choice. As you hopefully see as we executed these statements, it's not too difficult to trace the code through as long as you know what each statement does. Writing code is more difficult. Determining how to structure your program and where to use each statement is more challenging. This is the problem-solving aspect of computer programming. Determining exactly what steps will solve your problem requires practice and trial and error. Even when you think you have the correct algorithm, you may find it does not do what you want. This is when the debugger can help you as you step through it statement by statement and see when your program doesn't do the next step that is necessary to correctly solve the problem. Now that we have the expressive power the looping and conditional statements give us, we can solve more complex problems. It will likely take you more time to determine the correct algorithm, as you need to determine which statements to use and how to organize them. You are also likely to make more mistakes and your programs will not work correctly even after you fix any typos. The key is to not get frustrated, but instead use the debugger to see what went wrong, and then figure out how to change the code so it does what is needed to solve the problem.